All right, so today we'll look at our last section for the week, which is still section 2.1, just a little bit more material in it. We're going to look at two formulas in the section. Okay, the first one is what we call arc length, and the second one is area of a sector. So we're going to kind of figure out what the formulas are first, using what we did yesterday. And then after we figure out the formula, then I'll show you how to use it to do some calculations. All right, so let's start with that diagram. So in this diagram, I have two angles. Here's the ray, or the rays, for the first angle, and here's the two rays for the second angle. Now, each of those angles I've labeled. And usually in trig, when you want to label an angle and you don't know, you use a Greek letter. Okay, that's the Greek letter theta, T-H-E-T-A. So that little circle with a line in it, theta. Right. From angle theta, if you look at the two rays that come out, they hit the edge of the circle here and here. Between those 2 points, I've drawn an arc in red, and I just called that arc S. So arc S goes with angle theta, and then I did the same thing down here. Arc S1 goes with theta 1. So S1, theta 1, S goes with theta. Okay. So any questions on that picture? All right, so one thing I have to mention about this picture is that the size of the angle and the size of the arc are directly proportional. What does that mean, if two things are directly proportional? Anyone have a guess? Yep, Christian?
They're the same?
Not necessarily the same. We'll talk a little more about that. We're going to tie in kind of something that's the same with a fact from yesterday. But they don't necessarily have to be the same. Yep?
It means if you multiply one of them by a certain number, or divide by a certain number, you'll get to the other one, right?
Yeah, so directly proportional means, like, just a simple example. If you doubled the size of this angle, you would double the size of the arc. If you made this angle half as big, you would also make the arc half as big. Okay, that's what directly proportional means. All right, so because the size of the arc and the size of the angle are directly proportional, we can set up a proportion. Okay, that'll help us to figure out a formula for arc length. All right, so let's see if we can set that up. So proportion has 4 spots. Numerator and denominator on the left, numerator and denominator on the right. And you have 4 things. S, theta, S1, theta 1. So when you set up a proportion, you can do it a lot of different ways, as long as you're consistent. Whatever pattern you use to set it up on one side, use the same pattern on the other side. So I'm going to compare arc to angle. So S to theta. What do you think has to go on top on the other side, if I'm setting it up with the same pattern that I did on the left? Yep.
Like theta 1, because like gotta cancel out, yeah.
Well, it's got to be set up the same way. So if you had something like feet, inches, when you do it on the other side, it's got to be feet, inches.
So that'd be S1 then.
It's got to be S1. It's got to follow the same pattern on each side. We're not dealing with feet and inches. I'm just trying to show you an example. So S1, theta 1. Right? So S is to theta as S1 is to theta 1. That's what it means for things to be directly proportional. I'm just writing it out as fractions. Now, the problem is, if that's all you have, you can't do anything with that. You've got to have some numbers in there. Okay? That'd be like having a problem like this and just filling in 4 letters. A, B, C, D. Well, you got to know something. And with feet and inches, we do. We already know a fact we could fill in, that in 1 foot, there's 12 inches. How do you know that fact? Well, it's kind of the definition. In 1 foot, there's 12 inches. Now you could pick a number for C or D and fill it in and find the one you don't know. But this is the whole key. You have to start with something you already know. And that's what we have to figure out here. Okay, we have to start with something we already know. And there's something we can fill in here that we learned yesterday. So we're going to suppose that theta 1 is a certain size. Does anybody remember yesterday what we said about the size of the arc and the size of the radius? They would be the same if this angle was a certain size. Anybody remember what size that angle had to be? If we make this angle something, then the radius and the arc are exactly the same length. Yeah?
Is it 45?
No, not 45. Were you saying degrees or radians?
Degrees.
Degrees. No, not 45 degrees. Yeah?
1 radian?
1 radian. Okay? There's a fact, just like in 1 foot there's 12 inches. Well, a fact we learned yesterday, that if this angle is 1 radian, then that automatically makes S1 the same as the radius. It's just a fact, like in 1 foot there's 12 inches. So if that angle is 1 radian, then the arc is automatically the same size as the radius. So now we're going to substitute in those two things, just like I substituted in 1 foot there's 12 inches. So we'll substitute in and see what we get. S and theta, you're going to leave those alone. We're not changing anything with S or theta. We're just going to change S1 and theta 1. Those on the right-hand side. So we have left-hand side stays the same. For S1, we're going to make it R. And for theta 1, we're going to make it 1. And if it's a little confusing, like, well, how can you just let theta 1 be 1? Well, how come you can just let inches be 12? It's the same reason. It's just a fact. 1 foot, 12 inches. 1 radian, it's automatically equal to the radius. It's just a fact. Okay, so now the goal, I want to get S by itself. And when you have a proportion, how do you solve that? What do you do? Yeah?
Multiply by the reciprocal?
No. So sometimes we multiply by the reciprocal. We're going to do that today. We are going to use the reciprocal, but not for this one. Anyone remember how you solve a proportion? Yeah?
You cross multiply?
You cross multiply. So you do S times 1 and R times theta. So S times 1 is how much?
1S.
1S. And since it's just a 1S, we can just write S. And then R times theta. Not really anything you can do with it. And that is the formula that will calculate the length of an arc. Okay, there's 3 variables in that formula. S, R, and theta. You will always be given 2 out of the 3. Okay. So S is an arc length. R is a radius. And theta, that's the size of the angle in the problem. So that's your angle. But we have to be a little careful with the angle. Way back when we did this problem, we said suppose theta 1 equals 1 what? Radian. So this formula is built on the fact that we were working in radians. So if they give you a problem in degrees, first thing you have to do, change to radians. Okay, so S equals R theta. Yeah.
What if that supposed theta 1 isn't 1, what happens then?
Well, that's like saying, suppose there isn't 12 inches in 1 foot.
Okay.
There is. There always is. So, the fact that we used a 1, it doesn't really matter. Just like the fact I used a 1 here doesn't really matter. It's just a true fact. If you didn't want to use a 1, you don't have to. You could do it this way. You could say in 2 feet there's 24 inches. And I could have done the same thing here. I could have said suppose theta 1 equals 2 radians. And I could have done it that way, just like I did 2 feet. But then it gets a little more confusing because most people think it's easier to work with the number 1 than the number 2. But does that answer your question? Okay. All right. So always 12 inches in 1 foot. There's always one length of a radius in 1 radian. Always. Just a fact. Okay, so let's try an example. So there's a couple ways they can do the problem. They can write out the whole problem like I have here. Or in the next one we look at, just give you a picture. All right, so same idea. All right, so the directions are to find the length of the arc. And the important things are the angle in the problem is pi over 3 radians. And the radius in the problem is 4 inches. So find the length of the arc. Okay, so first thing you got to do is figure out, okay, what's the formula that I use? Because by the end of today, you're going to have 2 formulas. One for arc length, which we just did, and then I'm going to give you a second one. This is a problem about arc length, because it says find the arc length. Right, so first thing I would do is write down the formula. Next, I'm going to fill in everything that I'm given. And you'll always be given 2 out of the 3. Okay, so let's start with S. Joe, what does S stand for again?
S stands for the...
Can you help him out? Yeah, go ahead, Chris.
Arc length.
That's the arc length. Well, the problem is saying find the arc length. So we don't know S. So we'll leave that as a variable. The next thing is the radius. K, do I know the radius?
Yes, 4 inches.
The radius is 4 inches. Not too concerned with the label right now. I am concerned with the label when we write the final answer. So radius is 4. And the last thing is theta. Christian, what is theta?
Pi over 3.
Yep, it's an angle. And the angle in this problem is pi over 3. What's the unit on it?
Radians.
Is that the unit we want?
Yeah.
Yes. Pi over 3 radians. Perfect. Great. And now we just multiply it out. If you want to make 4 a fraction, you could always just put it over 1. You don't need to, but if you want to see it as a fraction, you could. And now multiply straight across in your fractions. 4 times pi over 1 times 3. And if they don't want a decimal, that's it. Other than putting a label on that answer. Okay, that's the answer.
And the label's radians, right?
Well, let's remember what S is. What is S? What's S, Joe?
The angle of the arc.
Well,
arc
the angle is
arc
theta.
length.
It's the arc length. So S is a length. So go back up in your problem. What unit did we use for length in this problem?
Inches.
Inches. So that is 4 pi over 3 inches. Okay, length, you always have to go back in the problem and look at what they used for units. In the formula, there's two letters that are both length. Radius is length, arc length is length. The only one that's not length is theta. Theta is an angular measurement, and you don't measure angles in feet or inches. You use degrees or radians. Okay. So that's the exact answer. If they wanted a decimal, we just do 4 pi divided by 3. That's about 4.19 inches. Okay. Any questions on that one? So they're all, for this formula, pretty much like that. Okay, a little different. This time they just draw a picture. And they want you to find the arc length of the arc. So what you're finding is this. If that red arc represented a piece of string and you took and straightened it out, put it on a ruler, how long would it be? That's what I want to know. Okay, so first thing is I'll start just by writing down my formula. Eric, what's my formula for arc length?
1s equals r.
Well, what's the final formula? So we went through a process to kind of figure out what the formula was, but then we put a box around, okay, and I put an arrow. Here's the arc length formula.
No.
Not sure? You can help him out? What is that, Christian?
S equals r theta.
Yep, S equals r theta. So that's the arc length formula. What we did in this before that was just kind of figuring out what the formula was. Now that we figured it out, we don't have to ever figure it out again. Okay, we know it's S equals r theta. All right, so write that down. Now we'll fill in what we can. Skylar, let's start with the 8 feet. What is that in the formula?
The radius.
That's the radius, yep. So that's my radius. The question is asking for the length of the arc, so I don't know S. And Oscar, what's theta here?
It would be 130
130 what?
degrees.
Degrees. Is that the unit that we want?
No.
No. So if you fill in 8 times 130 and do the problem, it's wrong. So off to the side, I'm going to take 130 degrees, and I'm going to change to radians. Okay, I'm not even going to do that out. I am going to reduce it. Can reduce by 10. And I can cancel degrees. So the angle that I want to use in this problem is 13 pi over 18. That's what you get if you change to radians. Any questions on that?
Wait, why did you just cross out the 0?
Because I divided by 10. I
Oh.
reduced it by 10. You don't have to, but it's just less I have to type into the calculator if I had to round it later. All right, so 13 pi over 180. Okay. Any questions on that? Yeah.
Isn't it 13 pi over
18, sorry. What I had over there, cross the 0 out. Thank you. I can reduce a little bit. 2 goes into 8 4 times, and 2 goes into 18 9 times. Okay, so we'll do that out and see what we get. So S equals, what's 4 times 13? What does that give me? Yep, 52. And don't forget the pi next to it. So 4 times 13 pi is 52 pi over 9. Okay, so not writing it as a decimal, that's the final answer, except for the unit. S is arc length. What were my lengths in this problem? Feet. So that's 52 pi feet. Any question on how you'd convert that to a decimal, if that's what they wanted? All right, so we've done a couple examples where we had to find the arc length. Let's do one where we have to find the angle. So the first thing they do is they tell us the arc length. This time the arc length is pi over 4 centimeters, and the radius is 12. Find the angle. All right, so let's start with the pi over 4 centimeters. Justin, what letter is pi over 4 going to get plugged in for?
I don't know what you call it, but like the circle and the line do it. Right?
Well, can you tell me, if you read the problem, what is the pi over 4 again? That's the, not the letter, but just tell me what it is. It's the arc length. So which letter there is arc length?
S.
S. So the pi over 4 is s. Okay, next thing it said we've got 12 centimeters. Okay, so Sam, what letter does that get plugged in for?
R.
R. So that's 12. And the question is find the angle. So that's what we don't know. Okay, so now we want to get 12 on the other side. So what would I have to do on each side to get theta by itself?
Divide by 12.
Just divide by 12. So divide by 12. That's the same as just putting times 12 in the bottom of that other side. It's like multiplying each side by 1/12. Or divide by 12, it's the same thing.
No, we do the 4.
The 4?
Oh wait, no matter.
4 is going to stay right there until I
No,
multiply.
yeah, I was looking at that wrong.
So divide that side by 12. 12's cancel. Divide this side by 12. You get pi over 48. And that's your angle. Now, I don't have a label on that angle. Do I need to write one?
Degrees.
Is the formula going to give me an answer in degrees?
Yes. Radians.
It's radians. The formula always gives me an answer in radians. And do I have to put radians?
No.
No. So I just leave it as pi over 48. Okay. Any question on that one? Right. Now, what would be a little tricky is, let's say this was a multiple choice question. And I gave you choices of pi over 48 degrees, pi over 4 degrees, and 3.75 degrees. One of those is correct. Anybody think they know which one is correct?
Would be a 2.75.
Yeah, it's the 3.75. It's not A. All the answers are in degrees. Okay? This answer is in radians. If you saw what I did real quick, I didn't know what this was in degrees. I don't know that one off the top of my head. So I converted that to degrees really quick, and I got 3.75. So the correct answer here, if it was multiple choice, is C. Okay. So just remember, the formula always gives you an answer in radians, but the multiple choices were in degrees, so you have to change it. Now, what if I did this? What's the correct answer now?
A.
Now A is the correct answer, because now the choices are in radians. Okay, so just watch for that. All right, so that's that one. And we'll try last one where you have to find the radius. Okay, just by looking at it, besides the fact we haven't found the radius yet, there's something there right away we have to deal with. Okay, we've dealt with it once or twice before, but we might want to fix this right away. Yep.
The 36 needs to turn into a radian.
Right, 36 needs to be converted into radians. And if you do that, 36 goes into 180 5 times. So you end up with pi over 5. That's not the answer to the problem, that's just converting degrees to radians. Any question on how I changed 36 degrees to pi over 5? Okay, so now we're ready to do it. Find the radius. So when I'm done, r is the only thing I don't know. So the arc length is 13 feet. The radius, I don't know. And the angle is pi over 5. So now, I want to get the pi and the 5 on the other side. And earlier someone mentioned something about, someone mentioned something and I said we're going to use that later. So there is a way to get the pi and the 5 on the other side at the same time. Does anybody know what you do on both sides here? Yep.
Times 5 over 5.
Yeah, times 5 over pi. And what's that called? the reciprocal. So we're going to times by 5 over pi times by 5 over pi. 5's cancel, pi's cancel. And now you're just left with r on the right. And 5 times 13 is going to give me 65. So it's 65 over pi. R is a length. R is not an angle. R is a radius. So what should be my units on 65 over pi? What is it?
Feet.
Feet. You remember R is the radius. So how long is this? That's measured in feet. Okay. So if you wanted to know, well, how long is that? Well, it's about 20.7 feet. So it's a little over 20 and a half feet long. Okay. Any questions on that one? So we've gone through that formula. Every way you can have a problem. Find R, find S, and find theta. Okay, so that's R. Okay. Last formula is area. So I'm going to start out with a diagram. Looks very similar to the one we did before. Except now I'm focusing on area. Okay, a sector, if you're not sure what that shape is, it's basically like a piece of pizza. It's got two sides that are straight, and then the top edge is curved. So if you had a round pizza and you let's slice it into like 8 pieces, each piece is a sector. So I've drawn two angles, theta and theta 1. And as the rays come out, they form a sector. Okay, the sector is right here. That's the sector. And then there's a smaller one right there. Now, the way we go about it is pretty much the same way. The size of the angle and the area that it covers are directly proportional. So what that means is if you make this angle twice as big, it would cover twice as much area. If you make the angle half as big, the area would get half as big. So whenever things are directly proportional, what are we allowed to set up and create like we did last time? A proportion. And that's exactly what we're going to do again. So we set up a proportion. There's many ways you can set it up, as long as however you set it up on the left, you set it up the same way on the right. Okay, so here are your 4 things to fill in. You have an A and an A1, a theta and a theta 1. Let's start on the left. Anyone think they could tell me one thing I could put on the left? Yep.
Area on top,
Area on top. Okay.
and then theta on the bottom.
Theta on the bottom. Perfect. Now that Joe chose to do it that way, we only have one way we can set up the other side. Okay. How can I set up the right-hand side?
A1 over theta 1.
A1 over theta 1. And if these weren't directly proportional, you couldn't do that. Something that's not directly proportional would be maybe like the more time you spend studying, the higher your grade is going to be. Maybe to an extent, but if you spend double the time studying, I can't guarantee you're going to get double as high of a grade. You know, if you spend 4 times as much studying, are you going to get 4 times as high of a grade on the next test? Probably not. So that's not necessarily directly proportional, but this is. All right.
You're saying we shouldn't study?
I'm not saying you shouldn't study, but I think there's a limit to, once you reach that limit, continuing to put more effort in may not continue to yield exponentially increasing results. All right, so we have to suppose something again, okay? And this suppose is based on a fact Just like you can suppose there's 1 foot, 12 inches. Okay, we need a fact. And we can't do the same thing we did last time. We can't suppose that this is 1 radian. Okay. It's a little harder to figure out what to start with this time. So I'm going to show you a picture. Let's start just by looking at this. Okay, you can just watch me draw it. What's the size of the angle that I just drew?
90.
90. And how much of the circle does it take up?
Quarter.
It takes up a quarter. Okay. So now, let's go like this. Okay, what's the size of the angle that I just drew there? 180. And how much of the... That's still a sector, technically. How big is it? How much of the circle? It's half of it. Okay. Well, let's say I did this. How big is that angle? It's 270, and how much of the circle does it take up? So now we have a sector that's covering 3/4 of the circle. Well, let's keep going. Let's say here's my initial side, here's my terminal side. So if the initial side and terminal side are right on top of each other, we've swung this side all the way back around, how big is that angle? 360. And how much of the circle have we taken up? 100%, the whole thing. So if the angle is 360, then the area is the whole thing. And if we already know a formula for the whole thing, then there's our connection. If the angle is 360, the area is the whole circle. So there's our connection. If the angle is 360, the area is the whole circle. We just need to figure out or remember what the formula is for the area of a whole circle. Does anyone remember what the area of a circle is? Yep.
Pi r squared.
Pi r squared. Now, we want to stick with radians again. So, what's 360 degrees in radians?
1. Just say.
Yeah, not 1, but yeah, 2 pi. There's your connection right there. That's not a formula, but that's the connection. That's just like saying 1 foot, 12 inches. 2 pi, pi r squared. If the angle is the whole is 360 degrees, or the angle is 2 pi, if the angle is the whole thing, the area is the whole thing. So that's the connection we can use this time. So let's suppose our angle is 2 pi radians. And if the angle is 2 pi, the area is pi r squared. And then area is pi r squared. Okay, so whenever you're setting up a proportion, all you have to do is figure out some true fact that you can fill in on one side. Any true fact. 3 feet, 36 inches. 5 feet, 60 inches. It doesn't matter. Any true fact will work. And then once you get a true fact on one side, you're good. Then you can fill in whatever they tell you in the problem on the other side. Okay? So let's substitute these in and see what we get. So we're not filling in anything on the left. We don't know the area. They'll tell us that in the problem. We don't know theta. They'll tell us that in the problem. On the right, we're going to plug in the fact that we know is true. 2 pi over pi r squared. And to solve a proportion, what's the name of the technique we use? cross multiply. Let's see, 2 pi, oh, thank you. Yeah, so the way we did it, area is on the top, and angle is on the bottom. I could have done it that way if I switched what was on the other side too, but it's not. So, thank you. So, area, top, angle, bottom. Just like in what I circled. Now, before I cross multiply, there's actually something I can reduce on the right-hand side. What cancels out there? The pi. Pi is gone. Okay, so all you're left with is a times 2, which we would normally write that way, 2a, equals theta times r squared. Or r squared times theta, same thing. Now, our goal is not to have a formula for double the area. I just want to have area. So, how can I get rid of that 2?
Divide both sides by 2.
Yeah, you could divide both sides by 2, or dividing something by 2 is the same as multiplying by a half. Okay, divide by 2, multiply by a half, it's the same thing. So, multiply each side by half, or divide by 2. Half of 2 is 1. So now you just have 1a, or just a, equals 1/2 r squared theta. And that's area of a sector. Just like the last problem, there's 3 variables. That's your area. What about r? That's going to be your radius. And theta is my angle. And what about that angle? It's what? It's the size of it, but what's the unit? Radians. Way back when we supposed it. Now, I could have done it with the 360, but if you do it with the 360, the pi's don't end up canceling out because you'd have 360 in the bottom, and then pi makes the formula look more messy. So that's why we chose radians. So it's the angle in radians. Okay, you'll always know 2 out of 3 of the letters. Fill in what you know, find the one you don't know. Okay, so any questions before we try? We'll try one of each this time. Okay. So I didn't write the problem out, I just drew a picture. And the question is find the area of the sector. All right, so now you have to decide which formula to use. You have 2. Well, if you look at the information you're given, the question is find the area. So you're using the area formula. And Mike, can you remind me, what's the formula for area that we just figured out?
1/2 times r squared theta.
Theta. Yep. And now we'll fill in everything. Okay. So Derek, what is the 4? What's that going to get filled in for?
That's the area of a sector formula, right?
That's the area of a sector formula. Yep.
Yes, for the 4,
Yeah.
that'd be the R.
Yeah. That's going to be the R. So let's fill that in. So the radius, in this case, is 4. And the angle, let's fix that. Joe, what's my angle?
Pi over 6.
And the unit on it?
That's radius.
It's already in radians, so we're good. Okay, so just follow order of operations when you do that. Start with your exponent. Okay, what's 4 squared? 16, and then half of it? 8. So I have 8 when I do all that out, still have the pi, and I still have the 6. That can be reduced a little bit. Christian, what can I reduce by here?
2.
Yep, reduce by 2. And the area is 4 pi over 3, but it's an area. So let me go back up. What's going to be the unit on that? Well, centimeters is a length.
Centimeters squared.
Centimeters squared, yes. Because area is two-dimensional. So, square centimeters. Okay, so any question on that? Area is always square something. Just go back up in your problem and look at the unit. Okay, so that's an example where you have to find area. Let's try finding R. Yeah.
What happens if you have to find only a section of that of the area, not the whole area? Then?
What do you mean?
So like, let's say there's like an arc in the middle that's like blocking off like halfway or whatever.
Like if the shape was different than a sector?
No, but like instead of having the whole sector, it's only like a clean arc in the middle blocking off.
Like another arc in the middle like this?
Yeah.
And what are you trying to find the area of, like this section?
Yeah.
Yeah, you could do that. Basically, think of it like if you had the area of this whole thing, and then you find the area of this smaller one, and you just subtract it,
That's what I was.
then you could find the area of this shape right there. Yeah, so you could kind of do something like that. It involves subtracting two areas. In fact, eventually we're going to do a problem later on, not this week, where it wants you to find the area of that little section. Well, if you can get the area of the whole thing, and then you can figure out the area of this triangle part, all you have to do is take the area of the whole thing and subtract the triangle part, and you're left with this little part right there. So we are going to do a problem kind of like what you said, but much, much, much later. Okay, so this one, find the radius. How do you know if you should be using the arc length formula or the area formula? Yeah.
Because it's not arc length, it's asking, it's 8 pi over 3 inches squared this area.
8 pi over 3 square inches, yeah, that's an area. So that has to be plugged into the formula A equals 1/2 r squared theta. So the area is 8 pi over 3. 1/2, we're just going to leave. Do I know r?
No.
Nope. So leave r the way it is. And theta. What's theta in this case?
45 degrees.
It's 45 degrees.
But it's not green.
But I need it in radians, which is pi over 4. If you changed, when you get used to radians working with 45s and 30s, you kind of just start to remember what they are. So I know 45 is pi over 4.
How do you know that? Like, how are we supposed to know that?
You can do it the way we learned yesterday. You could always convert it by hand. Yep.
Can you scroll above?
Okay, so goal now is to get r by itself. Let's kind of go one step at a time. Let's start with the 1/2. What could I multiply each side by to get rid of the 1/2? Yeah, you could start by multiplying each side by 2. Times 2. If you want to do 2 over 1, you can. Times 2 over 1. So when you multiply each side by 2, the 1/2 on the right cancels. You end up with 16 pi over 3 on the left. We still have r squared pi over 4. Okay, any questions on that stuff? Yeah.
Wouldn't that be 2 pi over 4?
On the right,
Yeah.
Well, the 2 canceled out with the 1/2. Because we had 2 times a half, so that's 1. Does that make sense? Any other question on that? Okay, so now we have to get the pi over 4 on the other side. What could I multiply both sides by to do that? Yep.
4 over pi.
Yep. 4 over pi. And 4 over pi. Pi's cancel. 4's cancel. Pi's cancel. So a lot of stuff just canceled out. So now we've got 4 times 16. If you do that, it's 64. Pi over 3 equals r squared.
I thought the pi's canceled.
Yes, thank you. Pi is canceled. That's what I said, and I didn't write it. Okay, so we're close. We want the radius. Right now we have the radius squared. So what do I have to do on both sides to get rid of squaring? Square root. So take the square root of that and that. Square and square root cancel. And now when you square root a fraction, you just square root the top and then you square root the bottom separate. Well, the top is nice. What's the square root of 64?
8.
So I get 8 over the square root of 3, and that's my radius. Now, the only problem is we generally don't like to leave a square root in the bottom. That's not trig, that's just algebra. Does anybody remember how you can get the square root in the top?
So it's like a negative, right?
We're not going to have to use a negative.
No, isn't that moving at the bottom?
Remember how you get the square root to the top? Well, yeah, Joe.
Don't you? Never mind.
What were you going to say? You started to say something.
I said, wouldn't you square the? I said, wouldn't you square it? But that would just bring us back.
Yeah, you don't want to square it. That would bring us right back to where we were. So the only thing you can do to a fraction that doesn't change it is multiply the top and the bottom by the same thing. That's the only thing you're ever allowed to do to a fraction that doesn't change it. So, did anybody see what you could multiply the top and the bottom by?
Both square roots of 3.
Yep. Multiply the top by the square root of 3 and the bottom by the square root of 3. So now in the top, you have 8 square root of 3. And in the bottom, you have the square root of 3 times the square root of 3. That's the square root of 9, which is 3. Somehow I deleted the problem. I'll get it back. All right, so square root of 3 times square root of 3 is square root of 9, or 3. So this last step, again, that's not really trig. That's just getting a square root out of the bottom. And if it was a multiple choice question, they will always do that. Okay. R, is that an angle or is that a length? Length. What are my lengths in this problem? Inches. Yes. Area is inches squared. Lengths are inches. Okay. So that's the longest one. We have to get R because of the square root. And the last one. So this time the area they're giving you, the radius they're giving you, they want the angle. Okay, so give that one a try. See if you can figure out what the angle would be. And then we'll go over it together in like a minute or so. All right, so I know this is a problem about area because they're giving me area. So I'll write down my formula. Okay, and let's start with the pi over 2. Okay, they tell you to fill that in for A. Next thing is to fill in 3 for R. So we get 3 squared. And theta, there's the question mark, so we don't know. Okay, let's do out the arithmetic next to theta first. So what's 3 squared? 9. And then half of 9 is just 9 over 2. I would just leave it as half of 9, 9 over 2. If you write it as 4.5, now you're going to have to do arithmetic with decimals. It's going to get a little harder than if it's a fraction. So I wouldn't write it as 4.5. I would leave it like that. Now, what do you multiply each side by to get 9 halves to the other side? 2 over 9, and watch what happens. Times 2 over 9, times 2 over 9. The 2's end up canceling. Those 2's cancel, and those 9's cancel. Pretty much everything just cancels itself out. Had you changed 9 over 2 to 4.5, you wouldn't have seen that. Okay. So now you've got pi over 9 equals theta. And you're done. You don't need a label on that because it's automatically assumed pi over 9 is in radians. Okay, it's a lot shorter than the last one. Any questions on that? All right, so in the homework, there's a couple problems. One involves a clock. And if you think of like the minute hand and the path that it traces as the minute hand moves from, say, 12 to 4, or as it moves 20 minutes, what's the path that the minute hand traces? What shape is it? Yeah. Yeah, it's an arc length. And the radius is how long is the minute hand. So maybe the minute hand is 4 inches. Okay? So the path it traces is an arc. The radius is the length of the hand. The problem is the angle. How can you get... There is a way to figure out what that angle is. Thinking about a clock and all the numbers being evenly spaced. Any thoughts on how you could start to figure out how big this angle is? Yeah?
They all be 30 degrees.
Yeah, they're all 30, right? There's 12 sections on a clock. There's 360 degrees all the way around. Every section is the same, so they all have to be 30. So 30, 60, 90, that's a 120 degree angle right there. Of course, you'd have to change to radians, but that's part of one of the word problems. And then the other one involves a pendulum swinging back and forth. What's the shape, if you swing a pendulum back and forth, that it creates? It's another arc. And the radius in this problem is the length of the pendulum. Right? So there's a problem about a pendulum. It says something like maybe a 10-inch pendulum swings back and forth 20 degrees. How long is the arc that it's making? Okay? But as long as you can see that that's really just a radius and an arc length, you're good. Yep.
If you say it swings 20 degrees, do you mean from the middle it swings 20 degrees that way and 20 degrees the other way, or 20 degrees in total?
Yeah, I think they give you a diagram in the book. They make it very clear. But when I said 20 degrees, I meant the whole thing. So 20 degrees from max point on the right to the left. 20 degrees. But I think there's a picture in the book. It's clear. All right, so last homework assignment for this week, same as the page as last night, page 99. 71 to 87, just the odds, and 91 to 94, all. Okay, so I will be after school today for a little bit. Probably going to have to leave a little early because of the back to school night, because that's at 5. But if you want to come for extra help, I will be here for a little. And first test is tomorrow. You can have a reference sheet. You can use a calculator. And I think that's it.